What's going on, everybody? This is Dave from Steel City Drones Flight Academy. I got a really special program here today for anybody that likes FPV or all of our public safety that does SWAT, different type of situations with drones. This is the program for you. So we at Steel City Drones have always been looking for new SWAT drone technology throughout the years. Recently, I saw a video that really caught my eye that I really liked. And there is a company out here called P-TAC drones, and they offer customized drones for SWAT applications. So I reached out to the guys at P-TAC and got to talking to them, and then we were able to get together and organize a simulated active shooter at a high school, which we're going to talk about in a second. But there's a lot of things that we want to talk about as far as the technology that's used and how all this works, and there's a lot to it. So since this video is a rather longer video, on your screen you're going to see different things. If you want to jump to something more specific that you're more interested in, or if you want to come back and watch the entire thing in its entirety, you can do so, and that way we can help you jump around if you need to and you're pressed for time. So I would love to be able to introduce you to guys from P-TAC. This is Max McCoy and Josh Hall from P-TAC. Guys, thank you very much for coming.
Hey, thanks for having us.
So I want to start getting right into the audience about, what P-TAC does and, a little bit about your history.
First of all, thanks for having us. We really appreciate the opportunity to show the drone and get it out to the world. So I'm Max. So Josh and I are the co-owners of P-TAC drones. P-TAC stands for Precision Tactical. It's US owned. We build them in the US. We're comprised of a former Air Force veteran, former Apple engineer, and we consult with a former SWAT medic. So we bring in tactical experience, and we also bring in technical and technology experience. So what we offer that's going to be a bit unique is we only work with indoor drone systems and for emergency response teams. So what makes us special is we customize packages. So what we can offer tactical backpacks, cases, customize our modular drones. So what we really like to do is work with tactical teams and make it for that team specifically.
Absolutely, that's great. So we're going to be talking about a very specific model and product that you sell, which is called the Scout. So Josh, you want to go ahead and tell the audience exactly what the Scout does and some of the features and functionality of that aircraft?
I'll run you through some of the major things that we thought were important when it came to an indoor drone. So the first one, it has to be affordable. It has to be affordable to the point where it can be considered expendable. We're sending these drones into places with people that aren't so nice. A lot of times they have weapons. So this thing has to be able to be completely obliterated and not have a huge financial loss to the department or agency. The next thing that's really important when it comes to an indoor drone, it has to be super tough. These drones, they can take a beating. And actually, that's one of the things at the demo that kind of stood out to people that was impressive, was just how strong it was. The other thing is that it's going to need, because it's an indoor drone, it's going to crash. You can put every sensor in the world on it. Eventually, it's going to crash. So when that drone does crash, you need to be able to continue your mission. One of our flight modes, we call it flip over crash mode. So if the drone is stuck upside down, you have the ability to control props individually, but spin them in reverse. So the drone will literally flip itself upright, and then you can disarm your props, rearm, and continue to fly without ever even getting your hands on it or even getting close to the drone.
That's what impressed me on that demo that I saw from you guys, is that, yeah, so if this thing does get stuck, you guys were flying in a really small slide tunnels and stuff, and I think that you just deliberately stopped it right there just to show that if it did get stuck, what would happen. And I was just blown away by that.
Yeah, actually, that's a cool video too, demo of it, because it didn't flip on the first go. It actually hit something. So what's cool is, let's say you're tangled up under a chair. You can actually be upside down, kind of working this thing back, and you can upside down work it away from an object it's stuck on, flip it up, and then continue to fly. So it's a really impressive technology. It's so simple, but it's impressive. That's what's cool about it. what else is really impressive is our camera system on it. So it has front and rear camera systems that are extreme low light, and they run on an analog signal. The cameras, they only need 0.001 lumens to work, and the drone will almost always bring in enough of its own light. So you can be in a concrete room with no windows and still be able to see. Even in like gymnasiums and stuff, we've still had really good success with that. If it goes low enough, it switches to black and white, but even that's super rare. I mean, the video you saw, you could even see red pipes in this room that had no windows, no light. It was just the drone. You could still see the color of the pipes.
I can't understate how impressive that is. For any camera normally needs some level of light to be able to show something, and you can get amazing details out of that. And that's so important, because now, with that said, you do not need a thermal camera indoors. So that's going to scale down the aircraft, the systems more, as well as giving it a lot more lower of a price point that you're going to need to go with. So that was very impressive about that. Can you talk a little bit about, well, why you're going ahead and still using analog and standard definition for the camera feeds and video feeds, and why that's important that we need to do that?
Yeah, so we do run analog. Now, these are customizable. So if digital was a make it or break it, we can absolutely do digital, but there is a lot of drawbacks to that. The big one is analog. We're able to run that front and rear cameras. And it's just much easier. The other thing is with digital, typically you don't, when you're in these situations where you're behind concrete or you're flying through a school, you're behind brick and rebar, the digital signal, typically it's either there or it's not there. So with analog, you'll get whatever's available. You'll see whatever's available. So even if your signal's starting to degrade, you'll still see someone shoot across the screen. You'll see someone holding a rifle. The picture, whereas with digital, or I don't want to say every digital, but most digital systems, you either get that picture or you don't. So that's why we actually went with analog. Now, it's not set in stone, but we would highly, highly recommend sticking with analog, because of the access to those low light cameras and just that the way the signal works comparative to digital.
And you're trying to design a system that is the worst type of situation that you can get into, where you're going to go ahead and might have to penetrate through 4 or 5 sets of walls, concrete. Because if you didn't have to do that, why don't you explain, like, for example, let's say you wanted to fly this and do a distance check with this type of a drone. I mean, this thing could just go for, a long time. Why don't you talk about the actual radio frequency that it runs off of and that type of a range and that system, because it's very impressive.
Yeah, so we actually went with the Crossfire system. So, we're not reinventing the wheel here and upcharging it 5 times the cost. We just went out and found the absolute best possible signal penetration that's been tested time and time again. There's guys that are taking basically the exact technology we're using here, putting them in a different style frame, and quite literally flying them to the top of a mountain, miles out. So it's a really, really impressive technology. It runs on 900 megahertz. And something else that's really impressive with it that was really, really important to us is if you fly so far, eventually you'll lose your signal. You actually have the ability to advance forward to the point where you can regain that signal, never have to get your hands on the drone. It'll just pick up that signal. You just disarm and rearm it. It'll continue to fly. I don't know of any other drones that can have a fail-safe that you don't actually have to get your hands on, unplug and plug back in to get them to fly again. So that was by far the most important feature, one of the most important features to us for schools and things like that. Clear this fatal funnel, lose your signal, you go to this area that you've cleared, then you advance. So by far one of the most impressive features of it.
Right, and like you're mentioning, you're trying to have a system here that is going to be the worst type of situation that you can potentially get into. Is there anything else you want to talk about the Scout before we get into the active shooter situation?
Yeah, just one or two more things. No outside data connection, so there's no data being sent to any other countries or anything like that. And modular upgrades and modular repairs. So with the new laws coming that have already been passed, remote ID, things like that, when we see what that's going to look like, this drone should be very easily adapted to those technologies. So we're future-proofed, and also repairs, if you do somehow break this thing, repairs are cheap. So, but other than that, there's a lot more detail on our website about it.
Good. Now, I think that's also important to clarify something here, because I know there's probably some people in the audience that are thinking, how are you guys doing this without line of sight? If we as Part 107 operators have to fly a drone line of sight, and you're going to go ahead and you're going to fly it indoors and go around that stuff, how does all that work? Well, the answer to that is Part 107 and the FAA jurisdiction do not apply to indoor flying. If we're flying outdoors and flying in, then that part of the flight is under 107. And then we just have to make sure, if we are using goggles or something like that, that we have a visual observer right next to us to be able to get around that very easily. But that's just wanted to clarify that. I know that a couple people probably are thinking of and asking that question right off the bat. So with that said, let's go right into our situation and our test that we actually did. So we brought in 4 different neighboring public safety agencies. You guys did a really good job demonstrating all the equipment and the technology to them. And then we decided to go ahead and do a pseudo mock-up active shooter at a high school. And we did so for a few different very important reasons. The main reason is because we wanted something very challenging as far as building material, structure-wise, and also distance. Because if you see on your screen, the high school itself, just like most high schools, are a fairly large footprint on a facility. And we wanted to go ahead and really test our boundaries for not only building material and penetration of that, but also distance as well. So we thought that was very important to do. We could have very easily went and decided to go ahead and do this demo in a small house, for example. And then I decided to bring in an independent remote pilot for this situation that never used your drone or your equipment, your systems before, never seen your stuff beforehand, and allow him to be able to go ahead and use those controls. We were actually outdoors. We were about 150 feet away from the entrance to the high school. And then he went straight in and flew right in the front doors, which we could have very simulated. We could have opened up a very small window, and he could have flew right into that without any problems. And that is one of the things that I'm most impressed with on your systems, is the size of the footprint, that we can go ahead and come in through a very small window as opposed to a larger window with something that the Mavic 2 would have to clear. Once we reach inside, why don't you go ahead and take over, and what happened from there on the demo?
So the pilot got into the building, and what you'll notice in the demo is we entered from the south, and there's a hallway going north, east, and west, long hallways. So for anyone with tactical experience, you're going to know the keywords fatal funnels. So this school honestly was a tactical nightmare for any type of team. You enter in, and there's 3 vantage points for to be shot at, or whatever the case is. So we got in. The pilot went to the eastern hallway. And what's really cool about our system, because we have a front and back camera, there's no way anyone's going to sneak behind you, hide, run behind you, shoot from behind without anyone knowing. So we really have full visual intelligence from any kind of fatal funnel. And what's cool is because we have the front and back cameras, you can also turn it in the hallway and strafe sideways. And we're able to see through all the windows, all the classroom doors simultaneously without having to do 2 sweep throughs. So once we got through the fatal funnel, we got to the cafeteria, which another buzzword for tactical teams is your wide area search. So we don't have to spin our drone around 360, go to another spot, spin it around. We have both cameras. So we just go in, turn, continue going through, and we've seen everything in that wide area search within 1 or 2 seconds. What's cool about the desks, the eating tables, we can get the drone down and we can slide it throughout the underground, under the tables, and see everything. If someone's sneaking down, laying down, hiding behind the table, we can see it all. So we were able to clear, I would say, about 60% of this school, going through the hallways, the cafeterias, checking the classrooms. And we started losing a little bit of our signal, getting degradation, which was absolutely expected. We're working through, I think it was 4 layers of walls, rebar, cement. So we expected to drop out at some point. So we reached about 60% of the school. And then if you think from a tactical team perspective, once you've cleared even a hallway or a room, you can move your tactical team forward, set up shop. And what's cool about our signal, because it self-regenerates, you don't have to unplug the drone, plug it back in. So our signal self-regenerated, and the pilot just took off and cleared the rest of the school in one sweep. And then we got to the gymnasium, which I'll let Dave and Josh take over that part of the scenario.
It only took us, what, a few minutes to be able to cover that entire area, correct? So that's something that, we don't have to, with a drone that's more docile and harder to control, or have to be very more delicate with not making sure it doesn't crash and everything. Guys can go and clear a larger area in a quicker time frame, and that's really important to note. And then once we finished doing that, we decided to go ahead and do a separate demonstration in the auditorium there.
Yeah, the gymnasium was a blast. So we just started out, we did, we did a mock search, and we even got some chase footage from one scout to another. Gymnasium is where we got everyone on the sticks for the first time. That's never even flown FPV. And they did really, really well. It was super impressive. I mean, little hiccups here and there to be expected, but for never even flying FPV, these guys jumped on the goggles and were already flying around the gymnasium day one. And that was with no simulator training, no little tiny whoop training, nothing. They just did it. And what's impressive about that, these things crashed over and over and over again. And at one point, we were even pretending to shoot basketballs. So we would put the scout up and drop it through the net, and it would just crash, and totally fine. I think the most impressive move of the day, though, had to have been when Max told our FPV pilot, smash it into the wall. I don't think I was expecting like a dive with some full throttle just smashed, but we pancaked a lipo against the brick wall. The lipo actually gave out. The drone didn't, which was crazy impressive. And it looked like the drone was done. I was like, no. We got the battery, unplugged it. It was like, throw a battery on it. I chucked the drone out into the middle of the gym, and they just flew it. And they continued to fly that same drone after that crash, and continued to crash it.
Right. And then what I was most impressed about was when you guys were just going ahead and dropping this aircraft right into the basketball hoop without any problems at all. And then you guys not only did that and got it through, you decided to dive it and then crash down to the bottom and on the floor, and then get right up and flip it around and then start using it again. So that was just amazing.
Yeah, one thing that I want to point out, those were the same props that we used the entire day. So we crashed this thing, 15 times. It's probably not an exaggeration. You guys would agree. 15 plus times, just smash, through basketball nets. And they were even the original props. Right. So, this thing is really durable, really versatile. The gymnasium, if the gymnasium doesn't prove that, I don't know if you're going to come up with a test that does. So now, there's something that we should point out is that the Scout is a fully manual drone. So there is no position hold, there's no GPS, there's no altitude hold either. So that's something is a manual system. Now, I love that about this aircraft, and we're actually going to start using the P-TAC drones and start incorporating that into our flight training so that our students can get a taste and appreciation for what manual flying is like. Because I always categorize that when people are flying now the new drones that have all the technology in them, it's like flying with training wheels. At some point, you have to learn to take the training wheels off and fly if you want to be considered to be a good pilot. So not only are you going to be able to get and use this as a tool for public safety and SWAT, but you can really also use this as a tool for your flying techniques. So, we can help you get on simulators. You can fly simulators before you ever pick up a controller. Right. And then also we'll get, if it's something you want, we can get they're called tiny whoops, just little super ultra small drones. We can actually get those paired with the same goggles, or if you're going to use a screen, the same screen, controller, everything just uses the same stuff. So you can get tons of stick time sitting on the couch in your living room, just flying around your kitchen table. Can you guys go over and talk about the Scout kit? What do you need to run this, and what does a kit consist of? Yeah, so first off, it's a complete kit. It's everything you need. You're not going to buy this and have to go buy other stuff. We're going to make sure it's just there for you, down to the little tiny Allen wrenches, everything. But it all comes in a like rolling military style case that could be switched over to a backpack. But this case, you'll open the lid up and you'll see 2 monitors in the lid. So those monitors paired up with the front and rear camera for your spotter to watch. And the case can live on the back of a pickup truck. And let's say you have to get mobile all of a sudden. Well, instead of lugging this case around, you grab the monitors, pull them off, and you're holding the monitor going mobile with it. So you'll get 2 of those monitors. Actually comes with 2 scouts. Yes. And the 2 scouts, it can either be a primary and a backup, or if you foresee yourself using this more like flying security systems, you can have them set up on different models and different channels and bands, and you can have 2 flying security cameras that can send signal at the same time. So you get 2 scouts to do what you want. You get the transmitter controller, which is customizable. We prefer one that's super, super simple. No need for 1,000 switches. It's got 4 switches in total on the thing. And you're only going to use 2 of them, disarm and your flight mode switch. The other thing it comes with is FPV goggles, which is what I'd say 85–90% of people prefer to use. It just seems to be more accurate flying, but some people are better on screens. So you can just use screens if you want. Does come with those goggles though. And then, like I said at the beginning, all the miscellaneous stuff. So batteries, a high-end charger that can actually charge batteries off of a big LiPo. You can charge your phone off this thing. It's my personal charger. I love it. And then all of the small stuff like Allen wrenches, extra props, tool to remove the props, all of that extra 3D printed bumpers, things like that. So it's a kit. It really is a complete kit. You're not going to have to jump on Amazon and buy 20 other things to make this work.
Now, I'm sure there's some public safety agencies out there that are saying we have our own command vehicles where we have our own HDMI 50-inch monitors and all of our equipment is all digital. How can we incorporate this system into something that we have for our own vehicles?
Nothing is proprietary here. So if there's something you can think of, 9 times out of 10, we can make it happen for you. We're actually integrated into a drone trailer that one of the major law enforcement teams here use in a major city. And all you need is either a diversity receiver or a triversity receiver and a TV with some kind of red, white, and yellow input. And that's all you need. So you can mount a 40-inch TV in the back of an Explorer and have antennas running to it, or you can have a full-blown command drone station running the TVs in there. So it's entirely possible. It's cheap and it's easy.
That's great. Now, I guess the only thing that we should talk about that we haven't done so far is pricing. So, Max, you want to talk about what a typical price range of a kit like this will cost?
Sure, and I'll speak in ballpark terms just purely because of the customization package that we offer. Like the case versus the backpack will be a big difference, but most departments can expect between $4,000 and $4,500, and then the cost of an individual Scout or drone is only $1,500.
And to let our audience know, we're also going to be selling and incorporating the P-TAC drones as well. We're going to be offering them on our online training or on-site training. Anybody who buys one of these kits from us is going to go ahead and get access to an online course that we're going to show you step-by-step on how to set these up and get you going. And anybody who wants more of a on-site personal one-on-one training, we got you covered there. We're going to be offering that to anybody throughout the entire country. So we have you covered all the different ways there. So, and I found this to be really fun and a very cool project to work with you guys on. And I'm looking forward to working with you in the future. And I want to thank you again for all your time that you put into this. And I look forward to working with you in the future.
Yeah, thanks for having us. We're
Likewise.
super
Thanks
excited.
so much.
Yeah, so I'm putting up your information on the screen. So anybody who wants to contact you guys individually, ask you more about technical questions, etc., they'll know how to reach you and your website. And if anybody has any questions, they can also reach out to Steel City Drones. They'll be glad to step you through all that process one step at a time and get you pricing and quotes and training packages on anything that you need. So thanks again. Thank you for our audience, and we'll talk to you guys soon. Stay safe out there, and until the next video, thanks again.
Thanks.